What's going on, YouTube? Just helping you out here. For this video, we will be looking at some of the features of our 2021-2022 FLL Cargo Connect robot that's been featured in several of our recent videos. It's actually a rather simple design. It incorporates everything that's required for our chosen missions, and there's no extra attachments or modifications required during the round, with the exception of a minor attachment we put on for container alignment on the last mission. So let's get into it. Let's look at our drivetrain. So our drivetrain is comprised of a fairly wide stance front axle, which we use the smaller wide wheels. We find gives us a little bit more stability. Unfortunately, you don't go as fast with the small wheels, but it does give us good traction with the wide wheels, and the wide stance is actually good for the turning. We have this ball in the back. This was actually part of the NXT kits. It's a Lego ball, and it actually provides a really nice wheel. It's basically a three-wheel design, and it's a fairly wide stance and a fairly good distance between the front axle and the ball, which gives you good stability. And this really works out well if you have missions that you're driving over any kind of terrain or any kind of bumps or grooves or whatever in mission models. This actually works much better than the very small metal ball that typically a lot of the teams use for a rear wheel. Okay, so again, low profile, low center of gravity, and this ball, just like I said, it just snaps into a cage, and it's designed so you can shake it around. It doesn't fall out, so if you pick up your robot, you're not going to wind up losing it. It does, unfortunately, take up a little bit of room in the back, but depending upon your robot design, we made this a little bit longer to get the stability out of it. As far as the chassis is concerned, again, you want something very stable. You want something that's fairly rugged, that can kind of bounce around a little bit, be grabbed and not have a problem. We made a nice structural design here. Everything's clipped together fairly well. Alright, and the other thing we did was a good symmetrical design. So as far as our support and the way the robot is built, everything's pretty much symmetrical with the exception of this lift motor, which you can't really do a whole lot about that without just sticking another motor on the other side, and that is an option. In this case, this design dictated the one motor, so we do have a little bit off center, but again, a low profile, low center of gravity, and a wide stance helps to eliminate any issues we might have with that. Unfortunately, like I said, the robot won't go as fast with these smaller wheels, but seems to go fast enough for what we wanted to do. Okay, as far as sensors are concerned, let's talk a little bit about that. We used to have a touch sensor on here. We were not using the touch sensor. Really, the only sensors we have on here are these color or line sensors. And you'll notice that spacing is actually a very critical issue. These are spaced apart such that you can line follow with one, and you can pick up a cross line or a perpendicular line with the other one. So on the field, you'll typically find that they have a line that you can line follow, and then they have some perpendicular lines that you can pick up to stop the robot or reference the robot. So it's very important that your light sensors be spaced apart such that you can line follow with one and pick up a cross line with the other. If you make them too far apart, you're not going to be able to get the separation that you need. In addition, the distance between the table and the edge of the line sensor is also very critical, usually a few pennies worth. This is a little higher than we normally do, but this tends to work fairly well. If they're too high up, you're going to pick up a lot of ambient light. If they're too low, you're not going to get acceptable reflected light. So you want to make sure that these aren't too close, they're not too far away, and again, separated enough that you can get good line squaring if you want to use them for squaring on a single line, or that you can get a cross line if you're line following with the other one. The other kind of unique thing we have on our robot is our lift arm. Okay, and our lift arm is actually not very sophisticated design, but it's actually kind of a unique thing in that we put 3 gears on. If you notice the 3 gears, you do need an odd number of gears. They can be any size gears, but they do need to be the same gears. And what you can do is, if you have the top gear in line with the center line of the motor, and you gear it, you can make some kind of attachment at the end, whether it's flaps or a lift arm, that will follow the same level or stay level through the full excursion. And this makes it really handy for taking your containers and lifting your container and being able to keep it level at all times. Right? And that's what we chose to use for lifting containers and placing containers. In our particular situation, we evaluated requirements for this lift arm early on in the game and decided that we would like to be able to pick a container up off of the sorting station and place it pretty much in any of the mission models that required a container to be placed. That decision kind of unfortunately came back later on to be a little bit of an issue in that we cannot drop a container or pick a container up off of the mat. So there are situations where maybe we could have increased our score by being able to place a color container in a color circle, but unfortunately the design choice early on was to be able to lift it up off of the sorting station at its lowest point. So when it was all the way down, we could drive up to the sorting station. We didn't have to worry about positioning the arm, and we could be able to place it anywhere at any height that we needed. And the arm also needed to be able to go high enough to be able to press down on the arm coming out of the cargo plane to release the cargo out of the cargo plane. So again, we made some early decisions which allowed us to do certain missions, did not allow us to do the others, and we just pretty much had to stick with that. The length of this arm is also very critical. If it's too long, you'll have to be too far away from your mission models as you go through your excursion. Again, as you're driving along, it has to either be high enough to miss things, or it has to be an extension such that when you turn or push the extension out, you don't hit a mission model. So again, this is very critical. This arm is designed such that when we drive up to the sorting station, we have the closest one would be here, the furthest one would be back here. We can still pick up containers out of the sorting station with this arm at this length, and it's kind of just about the right length for reaching and pushing other mission models on the field. So again, this length was not just a random length. We chose that based upon all the different things that the robot had to do and make sure that it wouldn't get in the way. Okay, the other thing we have on here are these side arms. Okay, so we put these side arms on so that we could get things out on the opposite sides of the robot rather than the front. We started with this arm being able to go out to the front and realized that in order to push the train, we had to have something out on the side so that we could push the train. So the side arm is actually run by a motor that's embedded right down in here. We have a motor uses gears or some bevel gears, and I don't know if you can see how that operates in there. Okay, but we have a gear train that runs across this way, and we have a gear that comes over here and turns this shaft. Okay, so we originally had some missions that worked off of this arm, and we decided we really wanted to show that everything could be done with our lift arm. So instead of using this, we actually use this side arm to come down and push the train and also to lower the bridge. And that's kind of embedded in there, which is a bit of a problem if you want to fix something or change something. That motor under there certainly is pretty difficult to get out of there or to change, and usually we try to make it so our motors are external and very easy to swap out if something should go wrong. But that seemed to work out again fairly well. Again, this lift arm, you can put it down and bring it up very quickly. So again, we're trying to keep programming simple, trying to keep the time it takes to do the missions at a minimum. The other thing we did was we took off a touch sensor that was on the back of our robot we weren't using. We made this little dumping arm here. Okay, this is a little passive ejection or dumping mechanism. And that allows us to take a package, put it on the back, and we can just bump into the doorway, and that kind of just dumps that off of there. So again, a fairly simple design, no motors or anything required, completely passive, allows us to very easily take the package and dump the package off the back. All right, and that was added later on. So one of the things you might have seen looking through our videos is we started off showing kind of the progression of how we did everything. We started with one idea, and then as the robot was out there and we looked at where we were on the field and what we could do, figured out maybe there's some other ways we could use what's on the robot to do some of the other missions, and we kept adding missions. So this was one of the things we added later in the game. Actually works out fairly well. The other thing that's very important to notice in some of our videos is we tend to use field elements and the field as much as possible for squaring. So we actually didn't use the line sensors as much as we thought we would this season. The line sensors for our sorting mission are really just used to detect the longer line in front of the sorting station just for reference. And after that, everything was done by programming and turning. So we really didn't use the sensors that much. We did use the line sensors in the last mission to show line sensing and picking up cross lines, but we really didn't need to do it that way. That was just a choice to show what could be done, and the whole idea of our robot is to give you ideas and let you see how things can be done. The other thing that's kind of important to notice about how we did our missions is we use what's called a pivot turn. And unlike a turn where you're just turning one wheel, holding one wheel steady and turning the other wheel, we do pivot turns, which is one wheel forward and one wheel back. Not only is it a faster way to turn the robot, but it's pretty accurate in that you're always turning the robot around the center of the axle. Okay, so right in this, wherever that is, you're going to be turning the robot right about the center. So it's very quick, and because you're turning both wheels at the same time, you're never dragging any rubber on the mat, which when you drag rubber on the field or the mat, it's actually a little unpredictable, because you can have a rubber wheel that's maybe got some dust or dirt on it. You could have a mat that's dirty. So it's actually kind of nice. You do these pivot turns and they work out pretty well. They're fairly accurate, and again, the smaller wheels we found tended to make it a little cleaner, a little more accurate. We also noticed that in some of the missions that we needed some minor assistance. So everything we needed is on our robot. So for instance, we use this piece for the platoon truck. Notice the platoon truck actually slides right on our lift arm. That was again part of the design. Part of the design was such that when we're picking up one of these containers, we have a little room. We can be off a little bit when we're turning to pick up a container, and we can still get it. All right. The other thing is it had to be small enough to fit into here. So it fits into the platoon truck. And we originally thought we would be able to just lift up the platoon truck. Unfortunately, we couldn't. This lift arm isn't strong enough. So you notice if we turn with the platoon truck on there like that, we kind of get this dragging. So what we did was we just take this little pin, we stick this little pin in the front, and all that pin does is lift the front of the truck up, so it just kind of slides now. So that slides, there's no drag. So now when we rotate the robot, this is actually a lot more accurate. Actually, it's very accurate because it's just sliding and we don't have to worry about anything rubbing on the mat. The other thing that we did is in the very end mission, we needed to be able to take these containers and keep them in a fairly known location on our lift arm to place on the platform. So we have this little piece that just pops off of here, and it pops onto our arm. All right, and that allows us to now keep these shifted off to one side, because this robot, because of the wide stance for stability, could not get close enough to the wall to drop these on the platform the way we wanted to. Okay, so we put this attachment on here. Again, that just pops off and goes on here for storage. So everything we go up to the field with for our robot is right here. And because we get a little bit close to the field on our last mission, we just have this little piece on the side here, which was thrown on there to just try to keep the wheel from rubbing against the side of the field during the last mission. Okay, a couple last things I want to mention is we have this little pivot on the back here, a little beam that pivots. And this is actually to knock down the avoidance wall, okay, the accident avoidance wall. And we just turn that out, so when we back up against the avoidance wall, this will hit the yellow plate and not knock over the entire mission model. The reason that's on a pivot is actually because if we leave it stick out and we back up against the wall, that will stick over the wall and outside of the boundary of the field, which is not legal. So we leave that turned in. Again, it's on the robot at all times, so all we have to do is spin it and it's there for the last mission. Now, speaking about backing up to the wall, one of the last things I want to mention is that we have a flat back and we have a flat front. And the whole idea of this nice wide flat front and a flat back, we use, as we mentioned before, the mission models and the wall boundaries to align our robot quite regular. So every time we get a chance to square the robot up, we'll either back up or go forward against the mission model or the field, and that helps to square the robot so we know where we are. So that's it. That's our robot for the year. Hopefully we've answered some of the questions people have sent out to us in response to our video. Again, not a very sophisticated design, but we've been able to accumulate 520 points on our round in about 2 minutes and 2 minutes 20 seconds, something like that. And really, this is it. Nothing else on the robot. So that's about it for this video. Feel free to check out all the other LEGO videos in our playlist to the upper left. If you enjoyed this video, please drop a like. Leave a comment if you have any questions or an idea for a future video. And lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.